Hi guys, welcome to the session for the chapter Coordination Compounds, the most important PYQs. Including 2024 question we have to discuss. So a simple chapter coordination compound, the IUP, the oxidation state calculation, coordination number calculation, what are the different type of ligand, Werner's theory, valence, crystal field theory, application of coordination compound, color of coordination compound, stability of complexes, and the metal carbonyls. These are the isomerism. These are the main important area in the chapter. So what the question they were asked from 2024 board exam paper that we can discuss first. Question number 1 is given as define ambidentate ligand with an example. Many times they repeated the term-wise questions like what are ambidentate ligand, what are chelating ligand, what are monodentate, bidentate, like the crystal field splitting definition question we can expect. You know what are ambidentate ligand? What are ambidentate ligand? They are certain monodentate ligand actually having two coordination site, right? Actually having two donor atom, but at a time they can use only one site. For example, we studied cyanide. Its ambidentate ligand is NC, isocyanide. Here carbon is the donor atom, here nitrogen is the donor atom, but at a time they can use only one. So ambidentate ligands are certain monodentate ligand having two donor atom actually, but they can use only one at a time. That's called an ambidentate ligand. Second one, what type of isomerism is given by? What type of isomerism is given by this complex? You may study different isomerism, structural isomerism and stereoisomerism. Correct. So here you can able to see that same formula, but what is the difference? Here chlorine and sulfate get interchanged. What is the name of this isomerism, my dear? That's called ionization isomerism, right? That is called ionization isomerism. So what is mean by ionization isomerism? This isomerism is happened due to the interchange of the groups or ions from the sphere and the ion which is present outside. Basically, a weak ligand from inside and counter ion that these two are get interchanged is called what? A ionization isomerism. And define chelate effect. What is chelating ligand? Chelating ligands are bidentate or polydentate ligand, have an ability to form ring structure, ring compounds with the metal is called chelating ligand, and this effect is called what? Chelation. And how it affects the stability of complex? Yes, it increases. If there is a chelating ligand in the complexes, their stability increases, right? Ring compounds are more stable. There is an OR question. Find the coordination number and oxidation state. Find the coordination number and oxidation state of chromium in this one. Okay, let me calculate the coordination number. What is the coordination number? Cr is the metal atom given. What is C2O4? C2O4 is our oxalate ligand. 3 oxalate are there. Oxalate is a bidentate ligand. So each OX provide 2 sigma bond. So total 1, 2, 3, 4, 5, 6 sigma bonds are there. So what is the coordination number of the system? 6 is the coordination number. What is the oxidation state of the chromium? Let us calculate. 3 sodium as counter ion. 1 sodium charge plus 1. So 3 sodium charge plus 3 plus chromium. Let us take it X. Oxalate charge is minus 2, right? 1 oxalate minus 2. So 3 oxalate minus 6. Overall 0. Yes, X is equal to plus 3. So coordination number is 6 and oxidation state is what? Plus 3. Correct. Sodium 3, X, and as oxalate is minus 2. So 3 oxalate mean minus 6. Overall neutral. So X equal to plus 3. Correct. So this is 2024 question. Let's go for the next one. On another question from 2024, what is the secondary valency of cobalt? Dear all, secondary valency means what? Primary valency gives the oxidation state and secondary valency gives the coordination number. So let us calculate the coordination number of the system. Here cobalt is the metal given. It's connected to 4 amine, right? Amine is a monodentate ligand. Amine is a monodentate ligand. So 4 amine provide 4 sigma bond. And even chlorine also a monodentate ligand. So total how many sigma bonds are there? There is a total 6 sigma bonds are there. So coordination number here is also 6. And next question, what type of isomerism is shown by the following complex? Can you able to see what type of complex is this? Here H2O 6 times, here H2O 5 times. What is this? Hydrate, right, my dear? This is called what? Hydrate or solvation. Hydrate or solvation isomerism. What is mean by hydrate or solvation isomerism? Complexes having same molecular formula, but they are differ. They are differ in the number of H2O as ligand. Here you can see 6H2O as ligand, but here 5H2O as ligand. So same formula, but different in number of H2O as ligand. That is called what? Hydrate or solvation isomerism. That is another question from 2024. Next question. Write the electronic, again 2024, my dear. Write the electronic configuration of D4 ion on the basis of crystal field theory, yes, CFT, when delta O less than pairing, delta O greater than pairing. My dear, what do you mean by delta O less than pairing? You know, delta O lesser mean T2G EG level difference is lesser, right? That means there is a weak ligand. Delta O lesser, which indicating you that there is a weak ligand. What is our system? D4. You know, D4 we can draw like this. 1, 2, 3, 4. You know, weak ligand mean there is no pairing happen. So directly we can split them. First 3 put it down. First 3 put it down. What is that? They contain 3 electron. Last 2 orbital up. Yes, here. This is the system. What is this orbital? This is T2G and this is EG. How many electron in T2G? 3 electrons. So T2G 3 and EG contain 1 electron. This is the answer. And the one more question is there. What happened when delta O, second question, what happened delta O greater than pairing energy? You know, delta O greater mean there is a strong ligand. Delta O greater mean there is a strong ligand. If there is a strong ligand, what we have to arrange, my dear? That D4 system, how it exists. If it is a strong ligand, you know, electrons undergo pairing. So 4 electron, if it pair, what is the situation? 1, 2, 3, 4. Now you break down. First 3 down, first 3 orbital down, and last 2 orbital up. There is no electron, right? So this is our T2G, this is our EG. So T2G contain 4 electron, EG no electron. So this is what happened when there is a strong ligand present. So that is the first question. Next question. Find the oxidation state and coordination number of the central metal ion in this complex. Okay, let us calculate. Cobalt is the metal, right? First we can calculate the oxidation state. Cobalt oxidation state X. You know, aqua is a neutral ligand. Cyanide is charge is -1. En is a neutral ligand. Overall charge is +2. How much it is equal to? +3, right? Oxidation state is +3. Coordination number. What is the coordination number? Cobalt is the metal. You know, aqua is a monodendate ligand. Cyanide is a monodendate ligand. But En is a bidentate ligand. So 1 En provide 2 sigma bond. 2 En provide 4 sigma bond. 1, 2, 3, 4, 5, 6. Coordination number is how much, my dear? 6 is the coordination number. Most of the cases you will get either coordination number 4 or coordination number 6. Okay. That's a case they were asked from 2024. Now give the formula of the following complex. Let's discuss one question from 2020. Give the formula of the following compound. You know, by giving the formula, they ask you the structure. By structure, they ask you the formula. First one, potassium. Okay, what is meant by potassium? K. Tetrahydroxido. What is tetrahydroxido? OH 4 times. Zingate, Zn, right? This is the complex. But we want to make the overall oxidation state 2, my dear. As per now, we have only one potassium, right? So potassium charge is what? 1. Zinc charge, we don't know X. OH charge is -1, so 4H -4, overall 0, you will get is equal to +3. But we want to get it as what? 2. If you want to make it the overall oxidation state 2, what you have to make the change? You have to write K2. Then only 2 potassium comes, you will get overall +2. Clear? So in order to make the oxidation state same, you can make the arrangement in, you can make the rearrangement in which one? The counter ion number. And the second one is hexaamine. What is hexaamine? NH3 6 times. Hexaamine, platinum Pt, and 4 and chloride. Chloride means Cl. See, dear all, as per now, platinum X, amine, you know, 0. We have only 1 chlorine. So if you proceed with this one, you will get +1. But we need to get overall 4. right? If you want to get overall charge 4, you have to make it 4 chlorine outside. Then only you will get -4. Overall, you will get +4. Okay, counter ion adjustment we can do it. Next one, give the formula of the following compound again. Pentaamine. What is mean by pentaamine? NH3 5 time. Pentaamine. Carbonato. What is carbonato? CO3. Cobalt means what? CO. And outside what you have? Chloride. How many chloride? Let us check it. Cobalt oxidation state X. Amine 0. Carbonate you know -2. 1 chlorine -1. Overall 0. We are getting +3. Yes, we already need +3, so no need to make any adjustment. Here itself, it's correct. Second question B. B is given potassium. So what is potassium? K. Then tetracyanide. What is tetracyanide? Cn 4 time. Nickelate. What is nickel? Ni. Let us calculate how many potassium should be there outside. As per now, we have 1 potassium. Nickel X. 4 minus 4 equal to 0. X equal to +3. We want to get +2, not +3. So what is adjustment? Make it K2. If you write it K2, it will be 2. Yes, overall answer will be 2. Clear all? Very simple, making the formulas. Give the IUPAC name and the electronic configuration of the central metal atom in terms of T2G and EG. Apply crystal field theory. What is the complex given? K4MnCx. Let me write the name of the complex first. What is the cationic part? Potassium. So what is the name? Potassium hexacyanide, right? Potassium hexacyanide. Mn is in the anionic part, therefore manganate, right? Manganate. Potassium hexacyanide manganate. Calculate the oxidation state, my dear. Here 4 potassium charge 4, manganese X, 6 cyanide -6, overall 0. Yes, X equal to how much? +2. So when you're writing +2, yes, we can write like this one. So potassium hexacyanide manganate 2 is the IUPAC name. Let's write their T2GG configuration. We can apply the VBT also here. You know, remember the step 1, step 2, step 3. What is step 1? What is step 1? Write the ground state of the metal. What is the metal? Mn. You know, manganese atomic number 25. So how we write the configuration? Argon 4s2 3d5. Hope you, my dear students, you know that how to write it. Manganese atomic number 25, so we can write the configuration argon. You know, argon atomic number 18. Next 2 electron you should fill in 4s and remaining electron in 3d5. If it is 26 is the atomic number, argon 4s2 3d6. If it is 27, argon 4s2 3d7, like that. This is step 1. Let's go for step 2. Step 2 is the oxidation state. Oxidation state. Ground state, oxidation state. Here we can see manganese is in 2+ state. So what do you mean by Mn2+? Last 2 electron gone. So what is remaining? 3d5. 3d5 means how we can write it? This 5 electrons are there. But step 3 we have to identify the ligand. The ligand is cyanide, right? Ligand is cyanide. You know, cyanide is a very strong ligand. Cyanide is a very strong ligand. So what happened? Electrons undergo pairing. So electrons, when it undergo pairing, what is the situation? These 2 electron get paired. These 2 electron get paired. This 1 electron will be there. Yes. Now you split, my dear. First 3 orbital down. First 3 orbital down. Last 2 orbital up. This is called T2G. This is called EG. How many electron in T2G? T2G 5, EG 0. Correct. That's the answer. What is mean by chelating effect? Already we discussed. Chelating ligands are bidentate or polydentate ligand, have an ability to form ring structure with the metal and it make more stability of the complex. This is called chelating effect, right? Hope, my dear students, you study the definition, everyone. Next question, how can you show the complex? These 2 complexes are ionization isomerism. How you can show that these complexes are ionization isomerism? Let's see. In classes we studied what is the test for checking the ionization isomerism. Take the first complex CONH3 5 times Cl SO4. If this compound, when you treated with a mixture of, barium chloride and silver nitrate, what is the reagent we are using to identify the presence of a ionization isomer? Barium chloride and silver nitrate. If you treated this, okay, this is the first compound. Let me take the second compound also. CONH3 5 times SO4 and Cl. When this compound, if you treated with the same barium chloride and silver nitrate, can you tell me what can happen in this case? What can happen? See, my dear, this barium, if there is sulfate outside, it combine with the barium. It will form barium sulfate. You know, barium sulfate is white in color, white precipitate. If there is chlorine outside, it combine with the Ag, you will get AgCl, white precipitate. There will be difference, okay, difference in their appearance. So, barium sulfate, you get it if sulfate outside. Chlorine, if it is outside, you will get AgCl. And one more thing, don't forget, sometimes they give you bromine, then it will give you AgBr. Its color is pale yellow in color. That also noted. Mainly they ask you these three: barium sulfate, silver chloride, silver bromide. Okay, so this is the test to identify the ionization isomer. Which one? Barium chloride and silver nitrate. If sulfate outside, you will get barium sulfate. If chlorine outside, AgCl. If bromine outside, AgBr. And write the next one question. Write the formula of the complex having IUPAC name potassium. Okay, what is potassium? K. Trioxalato. What is trioxalato? OX 3 times. And a chromate. What is Cr? Right? Chromate. And what is the overall charge you want to get it? 3. As per now, 1 potassium, chromium X. You know, oxalate charge -2. So 3 oxalate -6. Overall 0. X is equal to +5. But we need to get overall charge what? +3. What is adjustment, my dear? What is adjustment? We can do it here. If you write it 3 here, if you write 3 here, what it become? 3, right? So then it will be +3. Check it, all of you. So that there should be 3 potassium outside. So K3CrOX 3 times. That's a formula can be suggested for this complex. Write the IUPAC name and the hybridization of the following complex. First one, what is the name of this compound? What is the name? It's a tetracarbonyl. What is the ligand called? The CO carbonyl, right? So the name of the compound is tetracarbonyl nickel. Oxidation state is 0 because you know carbonyl is a neutral ligand, nothing else here. Whereas what is the name of this compound? Hexafluorido, right? Hexafluorido cobaltate. Why cobaltate? Because cobalt is in anionic part. Overall charge you calculate, my dear, you will get 3 and it is an ion, right? So we can write it as ion. Correct. Next one, we want to know that what is the hybridization of each case. Okay, let us calculate. What is the first compound given? NiCO4. Okay. In order to calculate the hybridization, we can apply our VBT, valence bond theory. What is valence bond theory? 3 steps are there, my dear students. I hope you know very well about this one. Step 1, write the ground state of the metal. Who is the central metal atom? Nickel. Nickel atomic number is 28. We can write it as argon with 4s2 3d8. And carbonyl is a neutral ligand. Therefore, overall charge of the complex is 0. So, no excited state required. Directly, we can go for the last step. Identify the ligand. Carbonyl, my dear, it's a strong ligand. Carbonyl is a very strong ligand. If strong ligand, you know, electrons undergo pairing. Means all electrons get paired from outermost, they come inside. So this 2 electron comes inside, it becomes 3d10. How d10 you can write it? D10 we can write it as like this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? This is your 3d orbital. I think your 4s orbital is free now. Your 4s orbital is free now because all those electrons come inside and get paired. And you know, total you have to accommodate 4 ligand. If you want to accommodate 4 ligand, we should have 4 vacant orbital, my dear. So 1 orbital you have after 4s who is free, after 4s 4p is free. Okay, this orbital we can mix it. This orbital we can mix it. How we selected the 4 orbital? Check the number of ligand, number of coordination number. 4 are there. So 4 ligands mean or 4 coordination number mean there should be 4 vacant orbital. So 4 vacant orbitals we consider. This is S and another one is P3. sp3, what is sp3 mean? Tetrahedral is the structure, right? sp3 mean tetrahedral. Let us go to the second compound is given as COF6 3 minus. Right? Here, which is the central metal atom that we can write it as step 1. Write the ground state of the central metal atom cobalt. Cobalt atomic number 27, that is argon with a 4s2 3d7. Argon 4s2 3d7. Next, what is step 2? Step 2 is that cobalt is in 3 plus state, right? So cobalt 3 plus mean lose outermost 3 electron. 2 from here, 1 from here. What is remaining? 3d6, 4s0. Now, let us see the ligand which is present. Ligand is fluorine, right? Fluorine, halogens, you know, they are act as weak ligand. Weak ligands mean no pairing. Okay, let me take it 3d6 here. How you write the 6 electron? 1, 2, 3, 4, 5, 6. And 4s is free now. This is our 3d. This is 4s. Check. Total how many ligands are there? 6 ligand, or 6 is the coordination number. If there are coordination number 6 or 6 ligand, 6 vacant orbital you have to be ready. So 1 is there. After 4s, you know, 4p is free. After 4p which is free, 4d is free. So let us take 1, 2, 3, 4, 5, 6. What is the hybridization? sp3d2. What is the geometry? Octahedral. sp3 is tetrahedral. sp3d2 is which one? Octahedral. So that is the hybridization. Let's go for the next question. Discuss the nature of bonding in metal carbonyls. As we discussed in classes that metal when bond with the carbonyl ligand form a double bond. Basically, all metals or ligands are making sigma bond with the metal, but carbonyl ligands have an ability to form double bond with the metal, right? And the one bond is sigma, one bond is pi. What is the extra bond we call synergic bond, right? Synergic bond. So they are asking you how the sigma bond and pi bonds are formed. You can write like this, my dear. Sigma bond is formed by the overlap between the sigma bond is formed by the overlap between empty orbital, especially d orbital, empty orbital of metal with filled orbital of ligand. Filled orbital of ligand, which means lone pair. You know, basically ligands contain lone pair or electron richness to the metal they are donating. So metal should contain vacant orbital, ligands contain filled orbital. These two overlapping and they forming a sigma bond or coordinate bond generally. So how the sigma bond is formed? It is formed by the overlap between empty orbital of the metal with filled orbital of which one? Ligand. Now we want to say how the synergic bond, the pi bond, extra bond is formed. Just opposite. It is formed by the overlap between empty orbital of the ligand, or you can say filled orbital of metal with empty or vacant anti-bonding pi star orbital of ligand. Anti-bonding pi star orbital of ligand. This is the way the pi bonds are formed. So clearly try to understand, my dear. Generally, ligands forms a single bond with the metal atom except carbonyl ligand. Carbonyl ligands have an ability to form double bond with the metal. You know, double bond means one sigma, one pi. Sigma bonds basically formed by the overlap between empty orbital of the metal with filled orbital of the ligand. But pi bonds are formed by the filled orbital of metal with vacant orbital of ligand. Which vacant orbital? Anti-bonding pi star orbital of ligand. That you may study in your MOT. A theory is called molecular orbital theory. Sigma, sigma star, pi star, anti-bonding, bonding. That's the case they are asking. So explanation of synergic bond is very important for our exam. Next one. Define ambid and ligand. Again repeated question. Ambid and ligand. Ambid and ligands are those ligands that can attach themselves to the other central metal atom through two different atoms, but at a time they can use only one, right? Ambidentate ligands are actually monodentate ligands, certain monodentate ligand. having actually 2 donor atom in present, but at a time they can use only 1. Now, write the IUPAC name of the complex. What is IUPAC, my dear? The ligands are En and chlorine, right? So, which is the ethylene diamine and chlorido, which is alphabetically ordered first chlorido. So, we can say dichlorido, bis, right? For En ligand, we will write 2 times means bis. Bis, ethane 1,2-diamine, ethane 1,2-diamine, okay? And metal atom is which one? Platinum. Can you say the oxidation state here? Platinum charge is X, En is 0, 2 chlorine minus 2, overall 0, you will get plus 2, right? So, dichlorido, bis, ethane 1,2-diamine and platinum 2 is there. Draw the structures of the geometrical isomer. What is geometrical isomer, my dear? Cis-trans isomer, this complex. What type complex is this, my dear? This is what? PTEN twice, Cl twice, right? What type complex is this? This is a type Ma4B2. What is Ma4B2? Metal is platinum. You know, En is a bidentate ligand. So, 1 En provide 2 bond. So, 2 En provide 4 bond. Therefore, A4 and B2. This type show the isomerism cis-trans. How can we place it? You know, this is an octahedral complex because coordination number is 6. So, let me place the geometrical isomerism here. Let me draw octahedral first. Now, we can place the species. See all of you? If you want to write the cis isomer, we have to place Cl adjacent. Then other 2 side En. So, this is the cis isomer. If it want to be trans, the 2 species should be opposite and other in this opposite side. This is the trans isomer. So, draw the cis and trans isomer of the complex. This is the type of the complex Ma4B2. The type Ma4B2 or Ma2B4 can show cis-trans isomerism. This is the way to place it. So, 2 chlorine same side, that is what cis. If 2 chlorine opposite, that will be the trans form. Next one, write the IUPAC name of the complex. What is the name of this complex, my dear? Amine is there, chlorine is there. Amine first. So, we can say tetraamine, dichlorido, right? Dichlorido, chromium. Chromium is in positive charge. So, chromium. What is the overall charge? Tetraamine dichlorido, chromium. Let's calculate the charge. Chromium X, amine 0, 2 chlorine minus 2, overall charge plus 1, X equal to plus 3. So, we can write 3, since it is an ion, we can write ion. Next question. Draw the structures of the geometrical isomer. Again, same type. This is a type Ma4B2. Same question. So, we can draw like this one. Cr. Make it a octahedral structure here. So, cis and trans, both of them we can draw it, my dear. Very easy. Let us draw the cis isomer first. Let me place chlorine here. And remaining side which one? Amine. Yes, this is the cis isomer. How can you draw the trans isomer? Chlorine opposite, other side NH3. We can draw like this one. This is the cis isomer. This is the trans isomer. Correct. Next, using the IUPAC norms, write the formula of the complex. Again, 2019, first question. Pendaamine. What is pendaamine? NH3 5 type. Nitro O. What is nitrito O? Nitrito O means ONO. Cobalt, okay, CO is the metal and outside chlorine. Overall charge you want to make it 3. Clear all of you? Let us calculate as per this whether it's getting or not. Cobalt X, amine 0, you know, ONO minus 1, 1 chlorine minus 1, overall 0. Yes, we are getting plus 2. But we need to get plus 3. This is second question, okay, don't take it as the oxidation state. This is the third, 3 is the oxidation state. So, if you want to get 3 oxidation state, let me put 2 chlorine here. So, it become minus 2, overall it become plus 3. Correct? Okay, counter ion adjustment, we can do it. Second question, potassium. Potassium is K. Tetracyanide. I think we did this question before. Tetracyanide. Nickelate, Ni. Okay? Overall charge you want to make it 2. I think we need 2 potassium, my dear. Check it all. So, 2 potassium, 2. Nickel X, 4 minus 4 equal to 0. Yes, X is equal to what? Plus 2, correct. Yes, so this is the formula of the complex. 2019 again, out of this complex, which complex is paramagnetic, more stable, inner, high spin and all. So we can use our VBT question, right? So let me take the complex one by one here. First is given COF6 3 minus. Okay. So cobalt is the metal atom, 27 is the atomic number. We can write argon 4s2 3d7. Here cobalt charge value calculating, I think you will get cobalt 3 plus. 3 plus mean this 2 and this 1 gone, remaining 3d6 4s0. Fluorine is a weak ligand, so no pairing happen. So how d6 electron can occupy, my dear? 1, 2, 3, 4, 5, 6. Correct. Okay, this is the system. And what is hybridization? Can you tell me? 4s is free. Total 6 ligand we have to accommodate. So 6 orbital we needed. So 4s is free. 4p is free. After 4p, which one? 4d also we can take. So 1, 2, 3, 4, 5, 6. What is hybridization? sp3d2. You know, sp3d2 is octahedral and outer orbital complex, right? Outer orbital complex and high spin complexes. What do you mean by high spin? The inner orbitals are not paired. Have you seen inner orbitals? Many unpaired electrons are there. If they all are paired, what we call low spin. Here not paired, therefore it is high spin. And second question is given as second compound COEN thrice 3 plus. Okay, let us calculate. Cobalt again, cobalt 27 ground state. We can write it as argon with 4s2 3d7. Cobalt charge is 3 plus here. Same like this one, 2, 1 gone. 3d6, 4s0 remaining. Here, you know, En is a strong ligand. Ethane 1,2 diamine is a strong ligand. So 6 electron get paired. How 6 electron get paired? You can write like this one, 1, 2, 3, 4, 5, 6. So 4s is free now. Even 4p also free here. This is 4p, 4s, this is 3d. You know, total 6 is the coordination number, right? En is a bidentate ligand. So 3 En means 6 is the coordination number. So 6 vacant orbital we have to place it. 1, 2, 3, 4, 5, 6. What is hybridization? D2sp3. You know, D2sp3 means they used the inner d orbital. Therefore they called inner orbital complex and low spin complex. Why it's called low spin? See, inner orbitals are paired. Correct. Now let us go for the question. Which one is paramagnetic? You know, paramagnetic means they should contain unpaired electron. You see, here more unpaired electron, here no unpaired electron. So this is paramagnetic, this is diamagnetic. So this is paramagnetic. Second question, which is more stable? Stability question, if they ask you, first you check whether there is a chelating ligand or not. You know, fluorine is a monodentate ligand, but En is a chelating ligand. Ring compounds are more stable. So more stable is this one. Which is an inner orbital complex. This one is the inner orbital complex, right? And high spin complex is which one? This one. So by using VBT, all these kind of answers we can able to say very immediately and just apply the same rule. Step 1, step 2, step 3. Step 1 ground state, step 2 excited state means oxidation state. Step 3 identify the ligand. Strong ligand, pair it. Weak ligand, no pairing. Then identify how many vacant orbital, mix hybridization. Clear all? Now using valence bond theory, write the hybridization and magnetic character of the following complex. Very simple. Same concept we have to apply. FeCN6 4 minus. What is the name of this complex, my dear? Hexacyanidopherrate 2, you will get it. Calculate the oxidation state, 2 is the charge. So let me go for the step 1. Step 1 is iron ground state. Iron ground state, atomic number 26. So we can write like argon 4s2 3d6. Here iron oxidation state is 2 plus. So this 2 gone. Remaining is 3d6 and 4s0. What do you mean by 3d6? 3d6 means 6 electron. 1, 2, 3, 4, 5, 6 and 4s is free now. After that, what is step 3? Step 3, identify the ligand. Here all, cyanide is a strong ligand. So 6 electrons get paired. After pairing, how the 6 electron exists? 2, 4, 6. And 4s is free now. Even 4p also free now. This is 3d, this is 4s, this is 4p. Alright, next. Total 6 ligand we have to place it. So 1, 2, 3, 4, 5, 6. So what is hybridization? D2sp3. What is D2sp3? Octahedral. Now, here all electrons are paired. Therefore, what is the magnetic property? Diamagnetic in nature. Correct. That's it. Write the electronic configuration of D6 on the basis of crystal field theory. D4 system, I think already we did. Hope you remember. Like, can I do directly, my dear? What do you mean by D6? D6 means 6 electron present in D orbital. Okay. What do you mean by delta O less than pairing energy? Delta O lesser mean there is a weak ligand. You know, weak ligand mean how 6 electrons can occupy. No pairing, right? So 1, 2, 3, 4, 5, 6. Alright. This is when there is a weak ligand. Now you break down. You break into 3 orbital below. How 3 orbital? That's contain this electron. And these 2 orbital goes to up. That's what, this is T2G, this is EG. So T2G contain 4 electron, EG contain 2 electron. That's answer. And what about the next system? Delta O greater. Delta O greater means there is a strong ligand. If there is a strong ligand, how 6 electrons exist, my dear? They exist as 2, 4, 6. Now you break down first 3 orbital down. 2, 4, 6. Last 2 orbital down. Up. So this is T2G6 and EG0. Clear? So that is the way we can able to adjust the crystal field theory question. T2G, EG. Define the following terms with a suitable example. What do you mean by polydentate ligand? Polydentate ligands are the ligands having more than 2 donor atoms. Like, you know, monodentate is there, bidentate is there. Monodentate ligand mean they having 1 donor atom. Bidentate mean 2 donor atom. Polydentate mean more than 2 donor atom, like a tridentate, tetradentate, like that. One example we discussed, EDTA. What is EDTA? EDTA stands for ethylene. This is ethylene. Diamine. Tetra acetate. What is acetate? CO minus, CH2, COO minus, CH2, COO minus, CH2, COO minus. This is the hexadentate ligand. See, if there is a metal atom present here with 1 EDTA, see 1 EDTA having 6 donor atom. See, this oxygen negative charged positions are donor atom because they are electron rich. Even lone pair position also. See, 1 EDTA can form 6 coordinate bond or 6 bond with the metal. So it's a hexadentate ligand. More than 2 donor atoms. 6 donor atoms are there. That is called polydentate. What is meant a homoleptic? We studied what are homoleptic and heteroleptic complexes. Homoleptic complex means the complex which contain only one type ligand. Okay, only one type ligand. For example, COF6 3 minus. Here only one ligand is there. Which one? Fluorine is the ligand. This is called homoleptic. Same. What is heteroleptic? For example, CONH3 4 times Cl2 plus. Here you see different ligands are present. That is called heteroleptic. Hetero. Same ligand present, homoleptic. Different ligand present, heteroleptic. Clear all? That's a definition. Okay, so that is the part 1. Some question we discussed. I think 2019 question is this one. Yes, we have some more question to discuss up to 2012-11. We have to discuss. Wait for the part 2.